Hi, this is now the fourth video in the tutorial of which is called Introduction to Python. This is a course Digital Economy and Data Analytics. My name is Eike van Vuren and we have already done a couple of things in the previous videos. For example, in the previous video we have been looking at functions, which I would say was the first, a little bit more advanced topic in Python. However, we would like to go on to more difficult topics, and the topic that I would like to start with now is object-oriented programming, and we are going to then look at classes. Well, object-oriented programming can be used in Python. However, I'm not that sure whether you have ever heard about object-oriented programming before. Even though object-oriented programming also exists in R, I'm not exactly sure whether it was discussed in the introductory course to R. So therefore, the first question that arises, what is object-oriented programming? Well, from Wikipedia, this means that the written programs are based on objects that interact with each other rather than individual lines of code. That's of course a very difficult definition, and I do think that it might be better, instead of focusing on this definition, it might be better to simply look at some examples. And therefore the question arises, how are we going to define a particular object in Python? Well, that can actually be done by class, by this word class that we have over here. Another thing that before we actually go on with respect to object-oriented programming in Python, I should say that unlike in, for example, Java, object-oriented programming is not a necessity in Python. So that means that you can easily program a lot of things in Python without using any kind of classes. But they can actually, like in C++ and in some other languages, including of course R, they can be sometimes very, very helpful. So therefore, in order to introduce the idea behind classes or object-oriented programming, let's look at a very simple but I would say somewhat useless class that can be defined as follows. First of all, of course, we're going to get class. In this case, I'm going to define my class as being this my class that we have over here. Then we are going to have our double points in order to start a block, and then we are going to indent, of course, and we're going to say x equal to 5. So this is a very simple class that has one particular element, that is this x that we have over here, and that element always takes the value equal to 5, and we can actually not change it ourselves in our declaration. So in this particular situation, the question of course arises, how can we actually declare an instance of this particular class? Well, that we can do by simply writing p1. So in this case, we are going to have a variable p1, which is going to be of our class or object, my class that we have over here. And then we are going to, well, declare it by this my class. And because of the fact that in this case, there are no inputs into this class, we simply are going to get these parentheses over here. And then the question arises, what can we do with respect to this class? Well, not that much, but we can of course print its x, and that we are going to do by printing p1 and then this dot that we have over here. We have already seen a couple of times before dots in the case that we, for example, were using NumPy and linear algebra or linalg. Then we also have been using dots. Take into account that that is because of the fact that also NumPy actually is a class. Usually at the moment that we are going to have a dot, we are going to say that it belongs, or it actually, we could also pronounce this as its. So in this case we are going to have p1 its x, because of the fact that x belongs to this particular class. And in this case, of course, if we're going to print this thing over here, then we get a 5. Take into account that, as I already said, this class by itself is completely useless because of the fact that we could have done essentially exactly the same thing by simply writing p1 is equal to 5 and then print P1 itself and get a 5 as well. Of course, that would have been much easier to do, and probably also essentially, well, much more a clear way to do this. So in this case, it's not really a good thing to use a class for something as simple as having a variable that is always equal to 5. However, we should realize that we can do better things than this, and that is that typically what we would like to do is that we would like to be able ourselves to well, do inputs with respect to a particular class. That means then that different instances of a particular class, in our case my class, they are going to be having different values in a sense of the elements of that particular class. Well, let's look at a more interesting but still very simple example, and that's a class that we are going to call my university. Well, in order to have our inputs, we usually are going to do that by initialization. And in order to initialize, what we need to do is that we have then to have this init function that we have over here. That's a simple function within a particular class. Actually, the good wording of it is that as soon as a particular function belongs to a particular class, then we usually call it method. I'm not exactly sure why that is the case, but I will usually mix up methods and functions with each other. But well, in this case, we simply are going to have def, of course, as we usually have with functions. Then we are going to have this init, and take into account that you do actually need these underscores that we have over here. And another important thing that you have to realize is that the first argument of init always has to be equal to self. I'm going to say a little bit more about this in a couple of seconds, but take into account that apart from this first argument, we also do have some other arguments, namely name and place of our university. Well, then what we would like to do is that we would like to then introduce, say, essentially what we would like to have is that the class my university also is going to have variables that are related, of course, to the name and the place of that particular university. So therefore we are going to have then that we would like to have the name of the university. Well, the name of the university is always then used self, that is the same self as that we have over there, dot name. So it's essentially the class is its name, and then in addition to that we also have self dot place, which essentially means that it's the class is its place, and they're going to be initialized by the name and the place that we actually have introduced here as arguments. And take into account that because of the fact that this one is self dot name and this one is self dot place, well, it implies that this variable itself is not the same as the variables that we have over here. Well, this looks a little bit difficult, but take into account that it's actually in that sense not that much different from what we have seen at the previous slide. Here we also have seen that at the moment that we are going to look at, say, the classes, it's X, that we actually, at the moment that we have already declared the class as being P1, then we are going to have that P1 actually also has its X. The only problem that we have at the moment that we are here inside this init function is that we are inside the class and we actually do not know what actually the name is of the particular instance of this particular class. So therefore we simply give it a name, and that is this self that we have over here. Take into account, by the way, that we don't have to use self over here. Instead of self, we could of course also have written our own name, like for example this, which is more common in, for example, C++. However, take into account that it is default in Python to use this self over here, and I would recommend you to always use self over here, and then of course you also have to use it over there. Well, let's now look at a particular example in which we are going to have an instance of our class. So suppose that we would like to have our variable my university, which is it is an instance of this my university over here, but in order not to get a problem with respect to the same names, I have written it here a little bit differently. And in this particular situation, my university is going to be the University of Groningen. That's probably also your university. And well, we do of course know that the University of Groningen is actually situated in Groningen, so therefore we get this thing that we have over here. Well, then after that, what we can do is that we can then print my university, its name, that of course is going to give us the University of Groningen. And well, also what we can do is that we can print my university's place, and that actually gives us this place Groningen that we have introduced over here. Well, this is already a nicer example. Take into account, of course, that still we can think of much more useful examples in the future. But one thing that we have to take into account is that one thing that you might say, like, well, why can't we simply print my university itself instead of its name and the place? Well, take into account that that is possible, but generally it doesn't make that much of sense. And the reason behind that is because of the fact that we should realize that class my university actually is a pointer. And now I do not exactly know whether you know a lot already about pointers, but we should realize that pointers are different kind of variables, different from standard variables, like for example floats. At the moment that we have a float like my float that we have introduced before, then we should realize that that actually does have a value, for example half or 1. But we should take into account that pointers actually don't have these kind of values. Instead, what they do have are addresses into the computer's memory. We should take into account that these addresses, they're not that easy. They're not like well, physical addresses like Netelbosje number 2, but they're very difficult and hard to understand addresses that we have in our computer. And they don't actually mean anything to us as human beings. So therefore, it doesn't make that much sense to actually print out my university itself. However, we should take into account that there is a way to make the printing statement to have some meaning. Instead of printing out the, say, pointer, the address of the computer's memory, what we can do is that we can actually make it some sense. But for that we need another function into our class definition, and that's the so-called str function. That is the one that we are going to, well, that is going to be called at the moment that we are going to have a print statement. And in this case, what we could simply do is that we could, for example, return then the name of the particular university. So it might be so nice that if I would here not print my university's name, but just print my university, that I get immediately the name of the particular university, the university that we are talking about. And therefore what we could do is to, well, simply define our string, say, function, this function that we have over here, as well, returning the name of the university. That means, of course, it's going to be self and that then this dot name that we have over here, which is, of course, the same, say, self name that we have already introduced there. So that implies that at the moment that I'm going to write it in this format that we have over here, well, then again, what we can do is that we can then declare our my university, well, and that is an instance of this my university over here, and again it's going to be the University of Groningen, situated in Groningen. But then at the moment that we are going to print out now my university, then we don't get the address of this pointer that we have over here, but instead this is going to now give the University of Groningen. Well, we should also realize that we can also make our own functions in a class. So apart from having these two standard functions that we have over here, this one is more common than that one that we have over there, but both of them we can introduce. These are standard functions. We should take into account that we can also introduce functions ourselves. So one thing that we could do is that we could simply have a function that is going to return the place of the particular university. So then we are going to have here well, apart from already this init function that we have over here, that we have already introduced before, we can actually have a second function which is called get university place. Again, we need this self over here, and then we are going to return, well, selves its place. So that will actually give us the place of the particular university, the university that we have, of course, introduced already at the moment that we declared the particular class my university. So that we can do here again. So here again we have my university. That's an instance of this my university. Therefore, here, over here again we are going to use the University of Groningen, which is situated in Groningen. And then what we can do is that we can print my university, get university place, and that gives Groningen in this case. I would like now to go on with the next topic, and that's the topic of encapsulation. We should realize that one of the most important ideas behind object-oriented programming is to hide some important details of the class for the user. That sounds a little bit silly. Why would you want to actually hide some important details to the user? Well, the reason behind that is because of the fact that, well, users may not always be interested in all the details of a particular class. Think, for example, of a situation that you might already have seen before in R. In R, you can, of course, try to estimate a probit model. I'm not going to go into details here how to do that, but what we should realize is that at the moment that you're going to estimate a probit model, then at that moment in time, it is not that, probably for the most users, it's not that interesting to know how that actually that probit model will actually find its final results. The only thing that you would like to have is that you would like to be able to input the data into the probit model and finally to get the coefficients and probably maybe also the standard errors. You don't want to have all the tiny details that are necessary to actually get the coefficients and to compute the standard errors. Like, for example, calculating the gradient and maybe even the second order derivative of the probit model, or say looking at all the tiny details that we need in order to do the optimization process. All these things are not that important for the user, and therefore it is better to hide them such that the user doesn't have to focus too much on that. And that you can actually do as well at the moment that we are going to look at Python. But we should take into account that unlike, say, programming languages like C++, C++, and Java, we should realize that also are object-oriented programming languages. We are not going to be able to do that by the words private and public, but instead we should use, say, that in terms of the names of the variables. And that is to say that as soon as a variable name has actually 2 underscores before the name itself, or starts with 2 underscores, then at that moment in time, by definition, it's going to be, say, a private variable. The same is actually true at the moment that we are going to look at functions. At the moment that we have a function that starts with 2 underscores, then at that moment in time we should realize that that is going to be a private function. That means, of course, that this init function, that's a private function, whereas these 2 functions that we have over here, they're not private but public functions. Well, then the next thing that we then can do is that we can look at a very simple example in which some of our, say, variables are going to be private. For example, the name now of the university, it's going to be private because of the fact that we have these 2 underscores, but also the place is going to be private as well. And then we have 2, say, different functions that are going to return, say, the name and the place of the universities. Well, take into account that if we are going to do it in this way, that at the moment that we again are going to introduce an instance or declare an instance of my university, which we call my university as well, and in this case we simply are going to call it RUG, which is just an abbreviation of the University of Groningen. And then one thing that we could do, as what we have done before, is to get in fact the place of the university by simply writing down my university, its place. And in this case, of course, we need these two underscores because of the fact that the underscores were there as well. But take into account that because of the fact that it is now a private variable, this is going to give us an error. This is not allowed in this particular case because of the fact that from outside it is not allowed to access, say, private variables. From inside it is allowed. So for example here it is allowed to use the private variable name and as well here as the private variable place, but it's not allowed to do that from outside, and therefore this code will actually give us now an error. Take into account that based on this class my university that we over here, we can actually still get the place of the university, but for that we have to use this particular procedure or say function that we have over here. So in this case what we need to do is to write it as my university and then get university place, and that will still give us Groningen as it should be. Note that this also implies that we can actually now no longer change the values of the particular variables. That is generally is possible at the moment that we have a global variable. Then it's always possible to change actually even from outside to change actually the value of the particular variable, even though it's a variable inside of the class. But that's not possible now here anymore because of the fact that they're private, and that implies, for example, that at the moment that I would like to change the, say, place of the University of Groningen from Groningen to Leeuwarden, that's the capital of Friesland, then at that moment in time, well, in the usual case I would just simply have written my university, its place, equal to Leeuwarden. But in this case what I need to do is to have these two underscores over here, but that will give this an error in this case. And the reason behind that is because of the fact that place here is a private variable and therefore it cannot be changed. It can even not be accessed, but it can also not be changed from outside. That means that if I would like to give the user here the ability to change actually the place of the university, then I have to have an additional function over here that makes it possible to set in fact the, say, a new place to an existing university. But take into account that that might not always be a good thing to do. Take into account that in many situations what you would like to have is indeed private variables like the one that we have over here, and not allow the user to change, say, the values that we have already initialized. And the reason behind that, for example over here, it's immediately clear that it sounds a little bit strange at the moment that you're going to change in fact say the place of the university towards Leeuwarden, but you're not going to change the name of the university. So still the name of the university is now going to be the University of Groningen, but it's no longer situated in Groningen, but it's situated in Leeuwarden. It would not make that much of sense to just change the name of the particular university. Maybe if ever the University of Groningen is going to go to Leeuwarden, then probably it's also not going to get a name University of Groningen anymore, but most likely it's going to be the University of Friesland instead. So that implies that well, simply changing it might not actually be so so good in this particular case. And therefore it might be more beneficial that you at least do not give the user the opportunity to change this value towards Leeuwarden instead of Groningen. And take into account that this of course still is a somewhat silly example, but we can think of other examples in which it's immediately clear that you do not want some of the variables to be changed. For example, suppose that we have a particular kind of, say, class in which we define the global constant pi. And suppose that at a particular moment in time, a user of that particular class wants to say like, well, I don't like the fact that this pi is equal to 3.14 and something else. Instead, I would like to have it to a simpler number, say 1. But take into account that that will completely obscure, of course, or completely make your, say, methods that you actually have in your class, it could actually make them completely corrupt. So in that sense, it would be better to make them, in this case, this pi private, so that nobody can actually change it. I would like now to go on to another aspect of object-oriented programming, and that's inheritance. What we should realize is that it's possible for particular, say, classes to be children of other classes. And in order to explain that, let's look at a very simple example. Suppose now that we would like to look at a class which is called my faculty. And we're going to assume that my faculty is a child of my university. Then the first thing that we can do is that we can then, first of all, define our, say, init function. Well, then we, of course, get self. Well, we should realize that, of course, since faculty always belongs to a particular university, we still want to have the university name. So we have here name of the university. We have the place of the university. But now we also would like to have the faculty name, this faculty name that we have over here, because of the fact that usually a faculty has its own name as well. Then if we go on and look now inside of this init function, then first of all we are now going to see something which looks a little bit difficult, but it's this super that we have over here. Well, super in the case of, say, object-oriented programming actually refers to the father of a particular class. In that case, that is my university, and take into account that actually my university also has a function in it. That's this function that we have over here. It is private, but it can actually be called because of the fact that this is a child of my university. Therefore, it can actually, even private functions can actually be called. And then what we are going to do is that we're going to call this particular, say, function that we have over here, and it will then essentially initialize the name of the university as well as the place of the university. Well, and then we still have to, of course, initialize the faculty name as well, and that's what we do in this line that we have over here. And then finally what we can do is that we can make a particular kind of function, that is this function that we have over here, which gives us the faculty name. Now, what we can do now next is that we can now declare an instance of my faculty. We are going to call it, again, my faculty, which is this instance of my faculty that we have over here. Well, again, we are going to look at the University of Groningen. So we have RUG here again. We have here Groningen. And the faculty that we are going to focus upon here is the Faculty of Economics and Business. That is this FEB that we have over here. And then the next thing that we can do is that we can then print my faculty, and then we can actually have here dot get university name. And that will give us, in this particular situation, RUG, so the University of Groningen. And that should not come as a surprise, even though, of course, my faculty does not directly have, say, a function which is called get university name. We should realize that because of the fact that my faculty is a child of my university, and because of the fact that my university does have a, say, function, a public function, that is get university place, well, we are able to call this get university name from outside.